And sometimes they get real nasty, don't go there girlfriend, and they don't even give you a point. But what they do give you is enough information to be able to find a point using simultaneous equations. So let's have a look at a worked example that addresses this type of problem.
Okay, so this question says, find the equation of the line passing through the intersection of the line with equations y equals 3x minus 5 and y equals negative 2x plus 5 and has a gradient of negative 4. Okay, like always, what we need to do is write out the formula for the equation of the line. Y minus y1 is equal to m bracket x minus x1. And to be able to use this formula, we need to have a point and a gradient. Right, so let's write in first of all the bit that we do know for sure, and that is the gradient is equal to negative 4. It gives us that straight up, so we're going to just write that in here. Gradient is equal to negative 4. Okay, so what we don't actually know in this question is the point where it goes through, because what it's saying is it goes through the point where these two lines here intersect. So it's giving me information to find the point, it just hasn't given it to me directly. So what we need to do is we need to find where these two lines intersect. Now to do that, we need to use simultaneous equations. So let's write this out. We go y is equal to 3x minus 5, that's equation 1, and y is equal to negative 2x plus 5, that there can be equation 2. Alright, let's have a look. Have we got one of these pronumerals on its own? Well, we can see here that yes, I actually do have y on its own, so that means I'm going to use the substitution method. So what I'm going to do that is I'm actually going to put equation 2 into 1. Right, so let's have a look here. I've got y is equal to 3x minus 5, so where I see y in this equation, I can just write that whole equation here. So instead of writing y, I'm going to write 3x minus 5 is equal to negative 2x plus 5. And let's rearrange to solve for x now. So to do that, let's add 5 to both sides first of all. So I end up getting 3x, and the 5's of course will cancel out, is equal to negative 2x plus 10. Right, and now let's add the 2x to both sides in order to get x over here on its own. So you get plus 2x gets us 5x is equal to, these cancel out, 10. And of course when I divide both sides by 5, I end up getting x is equal to 2. Okay, so I have my x coordinate, now I need to find my y coordinate. So I can do that by substituting x equals 2 into either equation 1 or equation 2. Let's just do it as equation 1 for this example. Alright, so I go y is equal to 3x minus 5, and I know that my x is actually 2, so you go y is equal to 3 times 2, because I'm substituting x for 2, minus 5. Y therefore is equal to 6 minus 5, because 3 times 2 is 6, and therefore y is equal to 1. So I know that it actually goes through the point 2, 1, because my x coordinate was 2, and my y coordinate was 1. So let's write this information up here. It goes to the point 2, 1. Now I have a point and I have a gradient, so I can use this formula. Write out the formula. Y minus y1 is equal to m bracket x minus x1. Alright, substitute in now, so write out the point 2, 1, and the gradient m is equal to negative 4. Alright, this here being my x1 and y1, and let's substitute into the formula now. So you get y minus y1 being 1 is equal to m being negative 4, x minus x1 being 2. So you get y minus 1 is equal to negative 4 x minus 2. So let's expand the brackets now, and we'll put it in the form y is equal to mx plus c first of all. So you get y minus 1 is equal to negative 4x plus 8. Add 1 to both sides. These cancel out, getting us y is equal to negative 4x plus 9. That is y equals mx plus c form, and of course we can rearrange it to ax plus by plus c form by adding 4x to both sides. So you get 4x plus y is equal to, these cancel out, leaving us with 9. And we subtract 9 from both sides, gets 4x plus y minus 9 is equal to 0. That there is our ax plus by plus c form. Either one are correct. Alright, so it's now time to press pause once again and attempt the following question. Remember, of course, once you've done this, press play and check your answers out against mine. Alright, so to answer this question, what we need to once again do is go through and highlight key information. So it says find the equation of the line which passes through the point of intersection, so point of intersection between the lines, this one here and this one here. It has a gradient that is perpendicular to the line of this. Alright, So what I've gone and done here is I've written out the formula once again, and of course in order to use this formula to find the equation of a line I must have a point and a gradient. Well, if I have a look at the stuff that I've highlighted, the point of intersection is between these two lines, so I can't actually get the point directly from the information. And if I have a look at the gradient, it's perpendicular to this line, so I actually can't get the gradient directly from the question either. So what I need to do is I need to use this information that's been provided in order to find both of these things in order to substitute back into this original formula. Right, so let's have a look at the point. I'm looking for the point of intersection between these two lines. It is -3x plus y is equal to -4 and y is equal to 6x plus 5. Now if I know that the point of intersection is between those two lines, what I'm going to do is I'm going to use simultaneous equations. Right, I'm going to call this equation 1 and I'm going to call this equation 2. Now in this case what I'm actually doing here is I'm putting equation 2 into 1. Right, because what you can see here is I've actually got y on its own here, and that means that I can write 6x plus 5 wherever I see the y in the equation above it, which is here. Right, so I end up getting -3x plus y, being 6x plus 5, as we can see here, equals -4. I've now just expanded the brackets, and now what I do is I do -3x plus 6x becomes 3x, and then you've got plus 5 equals -4. Subtract 5 from both sides now, gets 3x is equal to -9. Because of course these 5's will cancel out. Divide both sides by 3 and you get x is equal to -9 over 3 is -3. Now that I've got my x coordinate, I can find my y coordinate by substituting x is equal to -3 into either one of these equations. Now if you have a look, I've got y on its own here, so I may as well use that. So I'm going to do x equals -3 into equation 2. Now equation 2 is y is 6x plus 5. So instead of writing my x, I'm going to write -3. So you got y is equal to 6 times -3 plus 5. Now 6 times -3 of course is -18 plus 5, and -18 plus 5 is equal to -13. That gives me the point -3, because x is equal to -3 and y is equal to -13, so -3, -13. And let's write that up here, -3, -13. Alright, I now need to find the gradient using the information that I've been given. Well, we know that it's perpendicular to the line -2x plus 4y minus 6 equals 0. So I've written that right here. I've written out the equation again, -2x plus 4y minus 6 equals 0, and of course I need to put into the y equals mx plus c form in order to be able to find out the gradient. So to do that I add 2x to both sides. These cancel out, leaving me 4y minus 6 is equal to 2x. Now I add 6 to both sides. These cancel out, leaving me with 4y is equal to 2x plus 6. I then divide both sides by 4, everything here by 4. That cancels out, leaving me with y is equal to 2 over 4x plus 6 over 4. And of course, the common factor between 2 and 4 is 2, so cancelling it down to 1/2, and you can cancel 6 over 4 down to 3 over 2. Right, so I now know that it's perpendicular to this line here. That means it's perpendicular to this original gradient. So that means m1 is equal to 1/2. So substituting to find the gradient of the null, or the gradient of the perpendicular, it's equal to -1 over m1, or that's this value of 1/2 here. So -1 divided by 1/2, Big Mac fraction, take the 2 up the top, -1 times 2 is -2, divided by 1, and of course is equal to -2. So my mn value, or my gradient of my normal, is equal to -2. Okay, so now that I've got my point and my gradient, I can substitute straight into this original rule of y minus y1 equals m bracket x minus x1. I've got my x1 value and my y1 value, and of course I've got my m value. So let's do that. Y minus y1 being -13, which we've got here, equals m being -2, x minus x1 being -3. Right, expand the brackets now, gets us y plus 13 is equal to -2 x plus 3, and expand the brackets again, gets us -2x minus 6. Now what we're going to do is we're going to subtract 13 from both sides. These cancel out, leaving us with y is equal to -2x minus 19. Once again, of course, this is in the y equals mx plus c form. To put it into the other form, what we're going to do is we're going to add 2x to both sides, and also add 19 to both sides. So it gets us 2x plus y plus 19 is equal to 0 for the form ax plus by plus c is equal to 0. And there you have it, a very difficult question made easier by the fact that we know that we need to always be looking for a point and a gradient in order to be able to find the equation of a line.
Thank you very much, guys, for tuning into today's very special episode, which was all about finding the equation of a straight line. We were just using some more complex skills. Now, unfortunately, Jerry couldn't make the episode today. I tried to wake him up, but he was still sleeping and still dreaming about the formula that he uses to find the equation of a straight line. Jerry, wake up, buddy. I need you for a maths video. Come on, wake up. Wake up, the camera's on you. We need you for a maths video. No, it doesn't look like he's going to join us today. Alright, sleep tight, buddy. Anywho, if you do still struggle with some of these questions, make sure you put a little asterisk next to them, bring them to class, and I'll make sure I'll help you out with them. Of course, make sure you stay tuned for the very next lesson, which is all about finding the midpoint and the distance between 2 points. And of course, like always, say hi to your maths teacher for me. Mawsy out.